In this video, we're going to deal with radicals. Two problems in simplifying radical expressions, and then one solving when we have a radical in an equation. So let's look at the first one. We have the cube root of 16x squared y to the fourth. So what we're going to look for are any perfect cubes that can be factored out. So let's rewrite these as powers. So the cube root 16 can be written as 2 to the fourth, x squared y to the fourth. What we need are perfect cubes to see if we can pull out of this cube root. So let's rewrite it that way. So by properties of exponents, 2 to the fourth I can write as 2 times 2 cubed. X squared doesn't have any perfect cubes in it, so we'll leave it alone. Y to the fourth does, because we can write it as y times y to the fourth. Now we'll go through all the steps in this problem, but probably you could skip a couple of these once you get the hang of this. Sorry, not y to the fourth, y to the third. This is a cube root. Now, property of radicals is they can be split up over multiplication or division, not addition or subtraction, but because it's multiplication we can split it up. So the two terms that have cubes I'm going to put together under a cube root. So cube root of 2 cubed y cubed times cube root of what's left over, 2 x squared y. Because here we're taking the cube root of perfect cubes. The cube root of 2 cubed is 2. The cube root of y cubed is y. So we have 2y times the cube root of 2x squared y. And we've simplified this one as much as we possibly can. In the second one, we have the square root of 9x squared plus 36. Now 9x squared is a perfect square, and 36 is a perfect square. So you might be tempted to say, well, this is equal to 3x plus 6. That is not true. You could not split up a radical over addition or subtraction. What we can do is look for things under the radical that may factor. For instance, in this one, I can factor a 9 out of both terms. So square root of 9 times x squared plus 4, which now I can split up the radical like we did last time. Square root of 9 times the square root of x squared plus 4. Square root of 9 is 3 times the square root of x squared plus 4. Again, you may be tempted to say, oh, well, that's just x plus 2. No, do not do that. You cannot split up a radical over addition or subtraction. This is as far as we can go. Now notice the last one's not an expression because it's equal to something. That makes it an equation. So we're looking to solve this equation. Anytime you have an equation involving a radical, when possible, you'd like to isolate the radical. Get it on a side by itself. Well, we don't need to add or subtract anything to make this happen, but we can divide out the 3 to make this thing a little easier to deal with. So we got the square root of x minus 1 equal to 5/3. Now, next step will be to square both sides. That's what gets rid of the radical. That's why we like to isolate it. It won't always be possible, but this will be one of the steps, squaring both sides whenever you're solving an equation involving a radical. So it's kind of like the radical and the square cancel each other out. And we get x minus 1 equals 5/3 squared is 5/3 times 5/3, or 5 squared over 3 squared. 5 squared is 25. 3 squared is 9. And then our last step is to add 1 to both sides. So we're going to get x equals 25/9 plus 1, which is 9/9. So we get 34 over 9, and we're done.